question for you. What if I want to integrate this function? What do you notice about it? Well, yeah. So part of me is going, wait a minute, Mr. Grimm. You want me to find the area under this curve forever? It feels weird, Mr. Grimm. Well, good, because it should. Secondly, I feel like that's x cubed over 3 from infinity, 0 to infinity, which means you have to do infinity cubed over 3 minus 0, which is, again, weird. Please never stick infinity in like that. That's disgusting. Okay? So, two things today. First of all, and foremost of all, when you have a situation where you have infinity of one brand or the other, or both. Could be going from negative infinity to positive infinity. I don't know. If you have one of them, what you must do is this. So we know that this is, in general, if you have the integral from some f of x dx, we know that the antiderivative is, of course, f of x, yes? Right? Big cap F. But what we're going to do is we're going to take the limit as x approaches infinity, because we can't really get there, you know, of this guy, minus, of course, is to f of 0, because any idiot can stick 0 in. That's not a problem. Right? That will go likewise if you're approaching negative infinity as well. Similarly. Yeah. Now, clearly, some functions aren't going to work. For instance, x cubed over 3. What is the limit of this as x goes to infinity? Oh, it's infinity. But you know what? I didn't really need to take the antiderivative to know that, because I'm pretty down with this function going up forever, and I'm pretty sure that if you go towards infinity, it's going to be infinitely tall, and I feel like that's going to be lots of infinity. That's too much. That's too much. So I feel like the only way that we might ever get something other than infinity is if the function was approaching 0. What if it was approaching 0? In other words, what about this function here, my good friend e to the negative x? What if I integrated him from 0 to infinity? Now, some people might think, well, it still goes to infinity, so it's still a lot. Maybe. Maybe not. Okay? And so we have to check it out. But clearly, it's going to 0, so you feel like it might be a situation where there might be what we call a finite area. You know, like 2 or 12 or 6.5 or e to the 2 or something cool like that. But on the last one, it was like, well, it's going up forever. I feel like that one's no chance of it happening. So, what is the antiderivative of e to the negative x? From whence did it come? But no, it came from negative e to the negative x, yes? How did you do that? Well, I did it with substitution in my head, didn't I? Didn't I? Yes, I did, by God. Now, there it is. So I'm going to take the limit as x approaches infinity of negative e to the negative x minus a negative e to the 0. I'll do the hard part. This is negative 1. So that part's 1. That's q. Now, what is the limit of this beast as x goes to infinity? Well, I don't know. We better autograph it. Well, I don't need no freaking Desmos. Isn't this guy right here e to the negative x? Negative e to the negative x? It is. And what is it? Where is it headed as you approach infinity? 0. Ta-da! Hey, what's 0 plus 1? It's 1. You mean to tell me if you go all the way to infinity, it only adds up to 1? Yes. That's what I'm telling you. Which is pretty freaking cool, to be honest with you. Now, again, one can see that the only way this is ever going to work is if that function is heading down and approaching 0, yes? If it looks like it's approaching 0, the only time a person is going to be like, I should check this. If it's headed up at all, or if it's headed towards, here's a fun one. Hey, here is arctangent. pi over 2, negative pi over 2. If I were to integrate from 0 to infinity, let's say of arctan dx, listen, there's no reason to do the antiderivative. Look at this. Mr. Grimm, if I added up all of these heights all the way to infinity, what would it add up to? Infinity. So that feels like this would be infinite area, yes? So, yeah, I would just say right now it's infinite area. Stop what you're doing. There's no reason to do an antiderivative. Again, the only ones that have a chance is if they are approaching the x-axis. They're the only ones. They're the only ones that have a chance, and they don't guarantee to work. Okay? So in a minute, we're going to do one in a minute. You're like, oh, that's pretty cool, Mr. Grimm. It is. But you'll see. Now, so the classic, of course, e to the negative x. What about this guy? 1 over x. This is the next classic. I'm going to go from 1 to infinity this time, because I can. Now, 1 over x, as you well know, looks like this feller. Yes? And it's clearly headed towards 0 as you head towards infinity, yes? Yes? So there's a chance this might work. There's no guarantee, but it looks like it's headed towards 0, so it might work. I don't know. What is the antiderivative of 1 over x? It is the ln of x. You're right. From 1 to infinity. Wait a minute. So I need to take the limit as x approaches infinity of the ln of x minus the ln of 1. Well, of course, the ln of 1 is 0, so that's key. Oops, I didn't hit shift hard enough there. There we go. And what is the limit as x approaches infinity of ln? Well, I don't remember. ln looks like this, doesn't it? Where is it headed towards as you head towards infinity? It's infinite, isn't it? Yeah, it is. And so our answer is infinite area. Or, check this out, we could also say it does not converge. Does not converge. Either of those would be hunky-dory. I mean, Lacey, I don't really care one way or the other. Lacey, I saw your birthday's coming up this week. You don't lie to me. What day is it? Because I totes can find out anyways. All right. All right. And so is yours, Opdal. No? Yes? Yeah. Thursday? Saturday. All right. By George, there he is. Now, I know, it's pretty cool. So, does not converge. Wait, Mr. Grimm. Mr. Grimm. Can you give us a rule? By God, I can. Thanks for asking, Opdal. Opdal, if you have x to the minus p, where p is bigger than 1, it will converge if you're going from a to infinity. It will converge. What do you mean, Mr. Grimm? Well, I mean, let's think about this for a minute. I mean like 1 over x to the 1.1, that'll converge. 1 over x to the 9th, hey, that'll converge. Why? Because remember, this is just x to the minus 9, yeah? Right? The only one that won't is when it's 1 or bigger. 1, of course, what do you end up with? You end up with ln, which we just did, right? And if it was 0.5 or something, what would you end up with? If it was negative 0.5, you'd integrate, you get the square root of x. And what does the square root of x do? Does this thing, yes? Goes up forever. So the only ones that will converge, this is a fact, take it to the bank, is along that lines. So if they're a function that looks like that, if it looks like that, they will converge. For sure. Every time. And think about why that is. If you have x to the negative 9, and you would integrate that, what would you get? You would get x to the negative 8. Are you with me? And what does x to the negative 8 look like? It's negative, so it's down here, but it still approaches 0, does it not? But if you end up with something like x to the 0.9 negative, for instance, this would be x to the 0.1. Uh-oh. And x to the 0.1 looks a lot like this square root function, except, a little flatter, but still going up to infinity. Okay? So they have to be, have to be, for that p-value, this guy right here, has to be greater than 1. Okay? So when I say to the negative p, what I'm saying is that p value has to be bigger than -1. Or bigger than 1, I mean. Yeah. Yeah. So that's kind of neat. But Mr. Grimm, I want to do this one. Thanks, Lacey. This is exciting. I was hoping you'd actually suggest this one. So I'm talking about. Let's go from pi over 2 to infinity. Nice. Oh, no. Oh. This kind of stinks. I don't know what this function, that's a lie. I know what it looks like, but I'm going to graph it for you too, okay? So remember, if it does not approach the y-axis, the x-axis, there's no way on Earth it's going to converge. So don't even try. So we'll see if this one looks reasonable at least. So e to the negative x times sine of x. Ooh, say, does that star smell? As you head this direction, friends, does it approach 0? It sure does. It sure does. So it's possible that this one works, yes? Pi over 2 is about in here somewhere. If you were to add it up, this is a guess on my part, but from about here over, I feel like that's a lot of positive area relative to all this crap over here. Would I be shocked if it wasn't positive when I was done? I would be shocked. Now, you're like, cool. How do you take the antiderivative of this guy? Huh? What do you got to use, huh? Huh? It's literally been done in your notes. Integration by parts. That's right. And so you let u equal sine x and du equal cosine x dx, and dv is e to the negative x and dx, and of course, and v is equal to negative e to the negative x. And so you're like, wait a minute, you mean to tell me that to take the antiderivative of this thing, I'm going to take uv minus the integral of v du, that's correct. And then, oh, I got to do it again. Oops, that's e to the negative x, dummy. E to the negative x, there you go. There it is, cool. And so, of course, this side stays the same. This part stays the same. Plus, so then it's negative e negative x cosine x. And then it's this times this, and they're both negative, so then it's already a minus. So minus e to the negative x sine x dx. And then there's a positive here, so I don't really need that. That's cool. And then what do? Well, I add this fella to the other side, yes? Mm-hmm. And then divide out by 2. And so I say that e to the negative x sine x, it came from negative e to the negative x sine x minus e to the minus x cosine x all over 2. That's my antiderivative, yes? That is my antiderivative. And we've done that before, so it's not new. Right? Literally, that is the first one we did. One of the first ones we did the first day we did partial fractions. Or not partial, integration by parts, rather. Now, here's the thing, friends. I want to evaluate that guy as the limit of that as x approaches infinity. Now, the 2, of course, does not bother us, yes? Because whatever, it's, oops, what happened on top there, Mr. Grimm? Where'd your sign go? I don't know. I'm an idiot, I guess, whatever. There we go. That more better? Cool. Now, what happens to this? Well, the 2 doesn't matter, yes? The 2 is neither here nor there, because if it goes to infinity, it doesn't matter. But, so e to the negative x and e to the negative x, what happens to these guys as it approaches 0? It goes to 0, yes? And how do I know that? Because e to the negative x is dropping to 0 rapidly. And what's cosine doing? It's just flopping. So when I look at this, it's really just, it becomes, for instance, like cosine of x over e to the x, right? Right? And so who's getting to infinity faster? Well, the denominator is blown up to infinity. And this guy on the bottom, this guy on top is just jumping back and forth between plus and minus 1, yes? Right? And so what is this thing doing? This thing is approaching 0. Right? That's true for the cosine one as well, the sine one as well. So this piece here is 0. And then, of course, come back to the original problem, and we wanted to also evaluate it at pi over 2. And so I need to evaluate this guy at pi, so it's going to be 0 minus, it's going to be negative. This is the important part. This is where you will screw it up, most likely. Because you'll forget to put the parentheses right here, and it'll screw everything up. Hey, what's the cosine of pi over 2? Please get it right. Please get it right. Cosine of pi over 2. What is it? Do it in your head. Come on. Draw your circle in your head. Oh, here's 0 over here. What's the cosine? Oops, here's pi over 2, straight up and down. What's the cosine of pi over 2? How far sideways did you go to go straight up? You didn't. So that's right. It's 0. That's cute. And then, Mr. Green, what's the sine of pi over 2? I feel like that's 1, isn't it? Yes? And then 1 times this guy here is just that guy right there. So what you end up with is it's positive e to the pi, negative pi over 2 divided by 2, whatever that number is. That is the answer. I don't know what it is. You have a calculator. You could plug it in. Notice that it is positive value. It's a positive value, which is good because it's supposed to be positive. All right? Get your calculator out. Try it. What is e to the negative pi over 2 divided by 2? I don't know. I'm going to say 0.16-ish. That's what I'm going with. .24? It's e to the negative pi over 2. 0.103. Beautiful. So you mean to tell me, Mr. Groom, that the area from here, from that blue line all the way to infinity, that only adds up to 0.1. That's literally what I'm telling you. Literally what I'm telling you. Now, Mr. Grimm, can you do it as it goes to negative infinity? You know I can. I totes can. So let's do this one. Ooh, let's do this one. Nice. Let's look at that fella, shall we? Oh, friends, look at that. That's hot. What do you notice about it? Does it approach 0 as you head out both directions? It does. Question though, I feel like this is true. Maybe, you know, first of all, we have to do the antiderivative of this. Yes, in a moment. We'll do that in a moment. But keep in mind, if I do that, I might get some bizarre answer. Because what if it was 0 on both ends? If you take 0 minus 0, it's weird, right? You get 0, but clearly there's area, yes? So when we have a situation like this, what you need to do is break it into 2 pieces every single time. Now, what is a convenient place in the middle between negative infinity and infinity? Well, I think 0 is cool. But you could totally do 1. You totally could. If you're weird, you knock yourself out about that. Mr. Grimm doesn't care. Remember, you're going all the way to infinity. Does it have to be symmetric on both sides? No. So just don't get lazy and go, I'll just evaluate it on one side but not the other side. Ew, that might be a bad idea. And this one happens to be symmetric. But it may not be symmetric every time. What is the antiderivative of 1 over x squared plus 1? Don't screw this up. We just did these last week. What is that the derivative of? 1 over x squared plus 1. Come on, Hainsey. You're killing me, Smalls. If you were doing trig substitution and you saw x squared plus 1, you would think what?
You just said it.
Arctangent. Good boy. Nice work. So, turns out that this is arctangent. Well, now, I feel like that the arctangent of 0 is 0. That's what I feel like it is. Minus the limit as x approaches negative infinity of arctan of x. Oops. Plus the limit as x approaches infinity of the arctan of x minus the arctan of 0, which of course again is 0 on the top on this end over here. And so I get 0 on this end. Now, I need to know what arctangent looks like. Let's graph it, shall we? Nice. Nice. And as you come this direction, what is it approaching? It's approaching negative pi over 2. How am I supposed to know that? It's something that a fella or lady should know by this point in their career. And this guy is approaching pi over 2. So what is negative pi over 2? Negative and negative pi over 2 plus pi over 2. What does that equal? It's 2 pi over 2, which is pi. Nice. Meaning that on the original function, this green function up here, if you add up all the area under this curve, from negative infinity all the way to positive infinity, you get pi. You get pi. That's it. It's just pi. It's easy money. What's the matter? Look at it. Is it good? You good? Now, here's another question. Suppose I integrate this guy from 0 to 5. Do you notice any problem with that? Ah, infinity is not in one of the bounds this time. But where is it? Is there an infinity here? There kind of is. 1 over x looks like this. Yes? And so if one were to do this, one would get, for instance, the ln of x, yes? And you'd be integrating from 0 to 5. Well, the ln of 5, literally any idiot could do that. Minus the ln of 0. Uh-oh. What's the ln of 0? Go ahead and ask your calculator. Oh, Betsy, what's the ln of 0? Remember, she's going to say error, but that, of course, translates to you freaking moron. Yeah. Did you flip it off? Did you flip it off? Oh, okay, cool. Yeah.
Can you change that in the calculator where instead of saying error, it says you moron? That'd be cool.
I've always thought it'd be cool to put a little mini microphone inside one of those, a little mini speaker, to have it cuss you out when it happens, but I don't know how you can do that. It would be funny, though. It'd be hilarious. Now, friends, what does that mean? Why does that do that? Because the ln of x does this, yes? And what is the value at 0? It's like negative infinity. Is that going to be a problem? Yes. And what is that saying to me? Because it's the ln of 5 minus the minus ln of minus a minus infinity, basically, meaning that there's infinite area. Which means that this guy does not converge. Why is that? Because there's an asymptote here, isn't there? How high up does it go? All the way. How much area will there be? All of it. Yeah, exactly. It's not a finite amount. So this is the other kind of improper integral. That is, at one end, when you try to evaluate it, you're like, you can't do 1 over x at 0, Mr. Groom. You're right. That could be a problem. But it's imperative that one does not stick in the ln of 0 because one can't do that. But what one will do is take the limit as x approaches 0 of this. which again is still negative infinity, right? But you can't get to 0, so you take the limit as you approach 0. It doesn't actually exist at 0. Yes? Yes. Yes. Now, the next thing, Brooklyn says, Mr. Groom, I've often wondered about this one. Mr. Groom, I want to know how much area there would be between, oh, I'm not doing 5 again, between there and there. Seems weird, Brooklyn, but sure, let's do it. Sure. But wait, Mr. Groom, isn't it true that 1 over square root of x looks very similar to 1 over x? It is. Is there an asymptote at 0? There is. So shouldn't it just be infinite? No! And here's why. Remember, another way to write this equation is x to the minus a half. Are you with me? So let's antiderivative. So that'd be 2x to the 1/2 power, correct? And then, of course, one could say, well, that'd be 2 square root of 3 minus. And then we're going to take the limit as x approaches 0 of 2 square root of x. Well, what does this thing approach as you approach 0? What is this 2? What does the square root of x approach as you approach 0? That's the square root of x. This is 2 square root of x. What does it approach as you approach 0? 0. So the limit of that is 0. So it's 2 square root of 3 minus 0. So my answer is simply 2 square root of 3. Notice the difference. When you antiderivative this time, you ended up with the square root of x, which is perfectly hunky-dory at 0, yes? But last time when you antiderivated, you got the ln, which is not pleased about being anywhere near 0, yes? It's not pleased at being at 0. That is why we must take the limit here. Now, it's true, Mr. Groom, I could just actually drop 0 into this guy this time, yes? Because the square root of 0 is 0. Makes sense. Now, Lacey, the important thing about this is this. There are 2 types of improper integrals. Those that approach infinity, that is, you either have infinity here, or maybe both. And then there's the kind where you approach an asymptote. Doing, 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 doing. And those 2 are the 2 different kinds. But how do I approach them? Well, they're the same. I always am going to take the antiderivative. Yes? Let's say this is x equals b here. So on the top, so on this bottom one, I'm going to be going from b to c or something. So on this guy, I'm going to take the limit, or not, I'm going to take the limit, I'm going to take f of c minus the limit as x approaches b of f of x. And on this one up here, I'm going to take antiderivative, of course, from a to infinity. And so it's going to be, in this case, because infinity's on top, it's going to be the limit, hey, what's up, kid? As x approaches infinity of f of x minus f of a. You got something for me? Okay, the other 2 dingheads are in B29, but Lily's here. You can have her.
No, she can just continue working.
You want the lights on so we can see better? Are you sure?
Yeah.
I don't mind. Oh, keep working. Don't look at it.
Don't look at the camera.
Don't make that dumb look on your face.
I know it's awkward.
And blah, 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 blah. Nice work, kid. You're very photogenic.
Where are the other 2?
B29.
Thank you.
What's that for?
Your book.
What specifically? Like for like nerdy people? Oh, Alex Team. Beautiful. Beautiful. Thank you. Okay. All right then. What is another function I'd like to see? Ooh, I know. Let's do that one. What if I had 3 over 2x plus 5 squared? And let's go from negative infinity to negative 5. dx, of course. Mr. Groom, where should I start? Well, you should always graph it first and see if it even has a prayer of working. So was it 3 divided by? What was it?
3 divided by 2x plus 5 squared.
Ooh! So we are going from negative infinity to negative 5. Does it look like it's possible that it might have a finite amount of area? Yeah, because it's approaching 0 on the one end, clearly, yes?
Are we going to negative 5 or 5?
Did I say negative 5 or 5?
You said negative 5.
Negative 5. By the way, if it was positive 5, what would you say?
Wait up.
Take a flying leap, Mr. Groom. There's a freaking asymptote.
Wait,
Alright? But I didn't say negative. I said negative 5, not positive 5. What, dear?
it's 2x plus 5, right?
That's literally what I said, 2x plus 5.
Okay.
That's cool. That's cool. That's cool. That's cool. I only look at the graph to see if that even looks reasonable. Yes? Now, how do I antiderivatate this mess? Well, first thing I'm going to do is pull the frickin' 3 out front because it annoys me. Okay? And then what am I going to do? How do you integrate this guy? How do I do it? Isn't this a function, like in a function? So like u, 2x plus 5. And then du would be 2o dx. Yes? I don't have that. I have a half of a du apparently. So I'm going to have 3 halves. Integral of u to the minus 2 du. So look at it. You see it? Are you okay with it? Look at it again. If you're not cool, look at it some more. Right? Yes? Yes? No? Maybe so? I feel like that's pretty good, right? And so, of course, then if you resubstitute, you're going to get negative 3 halves. And then it's 1 over 2x plus 5, right? Or, hang on, negative 3 over 2x plus 5. Where did I lose you? Here? What about it? Where did that come from? Well, the 3 halves just came straight down. So I add 1 to the exponent. That's going to be negative 1. And then divide by negative 1. That's all right. And we're going from negative infinity to negative 5, correct? So I'll do the hard part. And then take the limit as x approaches negative infinity of negative 3 over 2x plus 5. Okay, now tell me, what is this thing approaching as you approach negative infinity? Well, I don't know. The top's a constant and the bottom's getting huge. So the whole thing is headed towards 0. That's key. And this fella over here, that's negative 10 plus 5 is negative 5. Times 2 is negative 10, right? So negative 3 over negative 10 is positive 3/10. 0.3 if you prefer. Ta-da! Answer. Answer. Now, I know what Brooke's thinking. So, Mr. Groom, you already wrote this problem up here. Can we just milk it for all it's worth, please? Because I don't feel like writing a new problem. Thanks, Brooke, I will. So, Brooke, I would like to think about this. It's 2x plus 5 to the minus 2. Is that right? Or to, right like that, right? But, Brooke, this time I want to go from negative 5 to, check it out, negative 2.5. What happens at negative 2.5? Freaking asymptote. And I know that without even looking because that's the value gives me a 1 on the bottom. Bam. Now, I don't know if this is going to be finite or not. So, first thing I'm going to do is antiderivatate this. Wait a minute. I feel like I already did this problem. Did I already find the antiderivative? I feel like I did. So, it's negative 3 halves, right? Well, whatever I wrote it as this, I think, right? I think that's how I wrote it, right? That's the antiderivative. Now, the 2.5 is where I have a problem, yes? So I'm going to take the limit as x approaches negative 2.5 of this thing. By the way, if it's infinity, you might as well stop because it ain't going to work for the other one. But I'm going to go ahead and write it up here just so that you can see what it would look like. Where, of course, that's a -5 in there, stupid. There you go. Attaboy. Cool. Now, we already know that this is positive 0.3 here. We know that. Duh. We literally just found out a minute ago. But here's my question. What happens to this beast as you approach -2.5? Well, the denominator is headed towards what? So that, what does that do to the whole fraction? It blows it. It blows it up. Hence, this is blown up to infinity. Which means this thing up here does not converge. Nice. 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 Oh, I don't feel good. What time is this class over? Oh, 36? Oh, okay, cool, cool. Now, just want to review something that I don't think we got to do much of first semester. I think we mentioned it. We talked about L'Hopital a little bit, yes? We talked about him, but we didn't actually do him. So, L'Hopital. And if you went to the thing, that was the one that the girl was having a conniption about. She's like, oh, he's so cute. Oh, my God, L'Hopital. Francois, blah, 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 French guy, L'Hopital. Right? Yes, I'm just jealous, probably. I don't know. It's all the girls. I don't know, whatever. No, there it is. L'Hopital. Now, here's his deal. He said if the limit as x approaches whatever of some f of x over some g of x is 0 over 0 or infinity over infinity, we say these are we say this is indeterminate form. In other words, 0 divided by 0, contrary to what Mrs. So-and-so told you, does not equal 1. Remember, she said anything divided by itself is 1. That's not true for infinity. It's not true for 0. So, well, how do we take the limit of it then, Mr. Groom? I'm here to tell you. So he said if you get one of these two values, then you will take this instead. You will take f prime over g prime and take the limit as x approaches a of that thing. Because it is the same as this guy. But if it's the same, why won't I get in 0 over 0? Because things change. Okay? If they're both going to infinity, then the question is not where they're going. The question is who's getting there faster. Right? And what does the derivative tell me? Rate of change. Speed, if you will, right? How fast are they getting to infinity? But wait a minute. What if this still is 0 over 0? Then do it again. And what if it's still 0? Do it again! Until you run out of stuff to do. Okay. Now, here is an example of one we just did a few moments ago. We did e to the negative x sine x. Mr. Groom, that is not 0 over 0. You're an idiot. First of all, thank you for noticing. Second of all, I feel like I can rewrite that just by using a little bit of algebra as the sine of x over e to the x. Yes? Like so. In a situation like this, you're thinking to yourself, hey, wait a minute. Do I have to use L'Hopital in this situation? Well, let's think about this. If you put in infinity, what happens in here? I don't know. Over infinity. But listen, I don't know IDK over infinity is not infinity over infinity, so I can't use L'Hopital in this case. I can't use it in this case. But I can sit there and think to myself, hey, this top number goes back and forth between here and here. Yes? That's what it's doing? And the bottom guy is headed towards infinity. So I don't care if you want positive or negative 1. Pick your biggest one. I don't care. Divided by infinity, you get 0. Right? Like, well, give us one that we have to use it on, Mr. Groom. I'd love to. Ooh. Oh, friends. If you head towards infinity, listen, I think I get infinity over infinity, don't you? Right? Yeah. Because they're both getting big, aren't they? So the question is not where are they going, the question is who's getting there faster. And now we know e to the x whips a quadratic any day, yes? But this is what we do. What is the derivative of this numerator? 6x plus 6, yes? And what's the derivative of our denominator? E to the x. Hey, what's the limit as that x approaches infinity of this? Oh, crap, it's still infinity over infinity. Ah, so L'Hopital says, do it again. That's cool. Now, what is the limit as x goes to infinity? Well, the top is 6. The bottom's headed towards infinity, so the whole fraction is headed towards 0. And that's what L'Hopital said. L'Hopital is kind of a big deal when you do improper integrals because infinity is going to pop up, well, a lot. And the only functions that we're going to be dealing with are ones that are headed towards 0, well, you know, all the time. If they're not headed towards 0, we're probably not interested in doing them because they're going to have infinite area. Okay, so L'Hopital will rear his head frequently in these chapters. Here's a fun one. Remember earlier we did this problem? It was the sine of x over x. And we just told you what the answer was. We looked at the graph, I think. What happens if you put 0 in? You get 0 over 0. Oh, that sucks. That's indeterminate, though. So what can I do? Take the derivative. Right? Now, what is the limit of this as x goes to 0? What's the cosine of 0? Cosine of 0. Here's my circle. 0 is over here. How far over did I go? 1. So the answer is 1. We also looked at this one earlier. Oh no, it's also 0 over 0. Oh dear. Oh dear. But, take the derivative, what do you get? You get negative, you get positive sine, I lied to you, over 1. And of course, what is the limit as x approaches 0 of that beast? It's 0, that's right. Yay. Yay. And so you'll see quite a number of those. I want to show you one more of L'Hopital. Just one more, if that's okay. This next one, some of you are going to hate it because you're going to it doesn't look like you said. I know it doesn't. That is not a division problem. Yeah, it is. Yeah? Nice. Now, one could start to see that after a while, what's going to happen here? It's infinity over infinity. If you take the derivative on top, you're going to get 2x over e to the x, which is also going to be infinity over infinity. You do it again, you're going to get 2 over e to the x, so the limit is 0, yes? One can see that that's going to happen the same basic way every single time. However, on this next one, it's going to blow your mind. You ready for it? I'm kind of excited for it myself. I'm kind of excited about this. What if I do e? No, not e. Wait, I have to think about it for a minute. I have to think for a minute. No. Yes, yes, x squared. Don't write it yet. Don't write it yet. No, 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 no. Yeah, that guy. Oh, wait. Is that what I want? Yes, that's what I want. Let's take the limit as x approaches 0. Oh no. What's going to happen? Well, x squared is 0. Yes, that's easy. But 1 over headed towards 0 is infinity. Yes? Coming from one side, let's go from the right side. So that's blown up to positive infinity. And then e to the positive infinity is going to be, well, I feel like infinity. So that's just weird. Notice how it is not 0 over 0 or infinity over infinity, yes? Could I fix that? I feel like I could. This is 1 over x, by the way. It just looks funny. Okay? I feel like I could probably do this. Wait, -2. Thank you. I could probably do that, couldn't I? How can you do that, Mr. Groom? Well, because it's the same as this. So I feel like I could do that. I also feel like I could do this. What's another way of writing this guy? That's right. So I feel like this is the same as that, which means I could also have done it this way. Right? Now, which of those is better? Well, here's my question to you. If you take the derivative of x squared and e to the x, is one of them ever going to go away? Yes, the x squared will go away, yes? If you take the derivative of this, it's just always going to flip-flop back and forth between e to the negative x and e to the positive, negative e to the negative x and e to the negative x. But this one will never go away, will it? Ugh, messy. So, when you're doing L'Hopital, you should probably think it through a couple of different ways. This one right here is the same one we just did a few minutes ago. It's just going to be 2e to the x. And then look what happens. Look what happens at 0. What do you get on top? You get 2. And what do you get on the bottom? You get e to the 0, which is 1. So the limit would be 2. And again, a person can check yourself with these, of course, by doing the original equation was e to the x squared, or x squared, e to the negative x. And was that what I had? Oh, thank you. Nice. Now, here's an issue. You're like, Mr. Grimm, did you mess something up? Yeah, I probably did. I probably did. When I look at this deal here, what happens is you're approaching 0. What is the limit? What is the limit? What is the limit as you approach 0? Exactly. But this time, that's why I mentioned over here, I was looking at it coming from the right only. Correct? Coming from the right only. So, let's flash back in time just a moment. Let's just see if Mr. Grimm didn't screw this up a skosh. Now, for instance, well, after I rewrote it this way here, after I rewrote the problem, right, then this is going to be 0 over 1, which is a problem. All right, go away. Have a nice day. We'll catch up tomorrow. I'll figure this out. And I'll just finish recording this and put it up, and you'll see it. It's going to be a good time. You got my keys, Levi? Hey, thanks, man.
See you, Mr. Groom.
Bye. That's so weird, dude. All right, so if you if you take the derivative, so it's e to the 1 over x times, this is x to the minus 1, so it's going to be negative x to the minus 2. And on the bottom, take the derivative of the bottom, you're going to get negative 2 x to the minus 3. And of course, if you take the derivative, so if you take and just flip these guys around, that's going to become x cubed on top and x squared on the bottom with the 2 there. These cancel. And so now what you end up with is this is going to infinity, this is going to 0, and you're like, okay, well, it's closer to what I wanted, but it's not exact. Okay, so it's still, indeterminate format. So let's go ahead and I'm going to put this guy on the bottom instead this time. Can I do it either way? Yes, I can. Okay. The derivative of this guy, of course, is 1. And it's 2. This is e to the 1 over x times negative x to the negative 2. Of course, this guy belongs up on top. Positive, there it is. So this becomes then, if I put that back up on top, it becomes e to the 1 over x times 2. And then, of course, this is negative 2 on the bottom, so it's up there on top. Now it's infinity times 2. And what does that say? It says as you're going at it from this side, it's headed towards infinity. There we go. Just got to not screw it up.